In this video, we solve problem 8.R.058 from the Larson and Edwards Calculus Early Transcendental Functions text, 7th edition. We're asked to find the indefinite integral. Now, for me, one thing that stands out is that I have a basic rule for cosecant of u. I know it's antiderivative. And I see that I have this square root function inside this trig function, and I have a square root in the denominator. And that is a pattern that's relatively common because if I take the derivative of x to the 1/2 power, which is the same as a square root of x, well, that's going to give me 1/2 times x to the negative 1/2. And what that leads to is a constant times a square root of x in the denominator. So this is a pattern that I recognize that I've seen many times before. So if I see a square root inside another function and then I see a square root in a denominator, square root of just an x or a constant times x, I know that I'm probably just going to use a u-substitution for this. But it's a little tricky. Some students will get bogged down in the algebra for simplifying this. So I'm just going to recommend a really easy way to get around the algebra, get around the chain rule and all of that you would be doing if you were to take this in the form that it's written. So let's say I want u to be this inside function. Like, that makes sense. That's a good choice for you. Now you have options with that. You could write that as 3x to the 1/2 power. And then if I take the derivative of that, I have to use the chain rule, and there end up being square roots of x everywhere. But what I would recommend, rather than using the chain rule to take this derivative, is just doing a little bit of algebra at the beginning to simplify this. And then it'll make the differentiation easier and then the u-substitution easier. So rather than writing this as 3 times x to the 1/2 and using the chain rule to compute du, let's use this fact. It's a fact that if you have a times b raised to a power, you can apply that power to each of those factors separately. Those are equal to each other. So this is really a square root of 3, or a 3 to the 1/2 power, which is the square root of 3, times an x to the 1/2 power. And now I can just think of this as a constant times x to the 1/2 power, and the derivatives are simpler, and you don't get bogged down with expressions involving a constant times x under radicals and multiple places and all that. So if I write u in this form, when I compute du, we just bring the square root of 3 down, and then we multiply by the derivative of x to the 1/2. So we bring the 1/2 down, and then we multiply by x to the 1 less power. And that's pretty nice. We know that x to the negative 1/2 is the same as 1 over x to the positive 1/2. And this 1 over x to the positive 1/2, that's what we have right here. So we can take this equation and solve for this 1 over the square root of x dx by multiplying both sides by the reciprocal of that, trying to get rid of that 2 over, or that square root of 3 over 2. So I'll multiply both sides by 2 over square root of 3. And those will reduce. And we find that du, or excuse me, 2 over square root of 3 times du is 1 over square root of x times dx. So we chose u, we did a little bit of algebra to simplify, then we computed du, and then we said we don't have this square root of 3 over 2 as a factor up here, so let's get rid of it by multiplying by the reciprocal. We ended up here, and now I'm ready to write everything in this integrand entirely in terms of u. So I'll do that, and I think I'll factor this a little bit as well. So I've got cosecant, excuse me, of square root of 3x, which is our u, and then I'm going to factor out that 1 over square root of x dx. So if I multiply this over 1 by this, I get this. And then if I want to write everything here entirely in terms of u, this just becomes cosecant of u by design. And this 1 over square root of x dx we know that that's the same as 2 times the square root of 3 times du, or 2 over the square root of 3 times du. And you can rationalize the denominator if you want to. You don't have to, though. I think WebAssign is fine with leaving that square root of 3 in the denominator. And then you just remember that you have a basic rule for the antiderivative of cosecant of u. It's negative natural log of the absolute value of cosecant of u plus cotangent of u plus c. And then, of course, you can back substitute. U is the square root of 3 times x. And that would give us our final answer. Now, if you wanted, you could write that as a square root of 3 times x to the 1/2, or a square root of 3 times square root of x. There's lots of different correct ways to write that answer. But I think this would be my preferred way to write it. So I would say the key here to making your life easier is to just take this and use this fact to rewrite it. And then this is just a very simple u substitution. We choose u, we compute du, we write the integral in terms of u. We anti-differentiate, and then we back substitute. And remember, back substituting means that we're replacing u with whatever it is in terms of x. In this case, that was square root of 3x.